Out in the silent dark between the stars, something moves. A ghost, a hole in reality itself. It drifts through the cosmic void, unseen and undetected, a shadow that bends the very fabric of space and time. This is not a monster from myth, but a force of nature, lurking in the endless night. It consumes light, so we cannot see it coming. Even the brightest stars are powerless against its hunger, their light twisted and swallowed before it ever reaches our eyes. It is pure gravity, a cosmic predator, a black hole. Its pull is irresistible, its appetite endless. Around it, matter spirals in, heating up and glowing in a final, desperate dance before vanishing forever. One of the universe's most profound and terrifying creations. Black holes are the ultimate enigma. Born from the death of giant stars, they are both destroyers and keepers of cosmic secrets. We've only glimpsed them from afar, but what if one entered our solar system? What if this silent predator set its sights on our home? Our solar system has been a clockwork of stability for billions of years. Planets and moons move in predictable harmony, their paths set by the gentle tug of the sun's gravity. Planets spin, moons orbit, the sun burns steadily. Life has flourished under this cosmic order, giving rise to civilizations that gaze up in wonder. But the universe is not always peaceful. Chaos lurks in the shadows, and sometimes the balance is shattered by forces beyond imagination. The arrival of a black hole would be the ultimate disruption. Its gravity would twist the orbits of planets, sending them careening into new, dangerous paths. Imagine the first signs. Astronomers notice stars vanishing, not in a flash, but as if a cosmic curtain has fallen. The sky itself seems to warp and ripple, a silent warning of the danger drawing near. Distant comets in the Oort cloud are flung about by an unseen force. Their ancient orbits, unchanged for eons, suddenly become wild and unpredictable. Calculations reveal the inescapable. Something massive and dark is coming. The numbers don't lie, and the evidence mounts with every passing day. The news spreads globally. Panic is certain. Humanity faces a threat it cannot fight, a force that cannot be reasoned with or stopped. How do you fight a hole in space-time? You don't. There's no weapon, no shield, no escape from its grasp. All we could do is watch and wait. The world would hold its breath, united in fear and awe at the power of the cosmos. We'd become spectators to the final act of our solar system. Our fate would be written in the stars, beyond our control. The silent predator, once a distant curiosity, would become our reality. Its presence would dominate the sky, a reminder of our fragility in the face of cosmic forces. Its approach would mark the beginning of the end. The harmony of our solar system would unravel, replaced by chaos and darkness. The cosmic order that gave us life would unravel. The darkness is coming. The sun's light would fade, and the planets would be lost to the void. Our familiar sky would become a stage for the universe's most terrifying drama. The stars we once wished upon would vanish, one by one, into the abyss. The end would not be loud or fiery, but silent and absolute. No explosion, no warning, just a quiet erasure of everything we know. The black hole would erase everything we know. Our history, our achievements, our dreams, all swallowed by the darkness. And we would be powerless to stop it. In the end, the silent predator would remind us of our place in the universe, small, fragile, and fleeting beneath the shadow of eternity. What is a black hole? These enigmatic objects are among the most fascinating and mysterious phenomena in the universe, capturing the imagination of scientists and stargazers alike. Its gravity taken to the absolute extreme, a force so intense that it warps the very fabric of space and time itself. Everything with mass has gravity: your body, the earth, the sun. Gravity is what keeps us anchored to the ground and holds the planets in orbit around the sun. Now, imagine squeezing the entire Earth into a marble just a few centimeters wide. Its gravity would become unimaginably strong, pulling everything nearby toward it. A black hole is matter crushed into an infinitely small point, a singularity where density and gravity reach infinite values, and the known laws of physics break down. Born from the death of giant stars, black holes are cosmic monsters lurking in the darkness, invisible except for the havoc they wreak on their surroundings. When a massive star runs out of fuel, its core collapses in a fraction of a second, triggering one of the most violent events in the cosmos. The outer layers explode in a brilliant supernova, lighting up the galaxy, but the core keeps collapsing under its own immense gravity. It becomes a point of infinite density. A black hole is born, hidden at the heart of the explosion. Its gravity is so powerful that nothing, not even light, can escape once it crosses the event horizon, the ultimate boundary. The event horizon is the point of no return, an invisible border in space, marking the edge of the black hole's influence. Imagine a river flowing toward a waterfall. At some point, escape is impossible, no matter how hard you try to paddle upstream. That's the event horizon for gravity, a boundary beyond which nothing can return. Once crossed, you're destined for the singularity at the center, pulled inexorably inward by gravity's grip. Time and space themselves warp near a black hole, twisting reality in ways that defy our everyday experience. For someone falling in, time slows dramatically compared to an outside observer. Minutes can stretch into hours, or even longer. Black holes aren't cosmic vacuum cleaners, they're deep wells in the fabric of the universe, warping everything around them. Objects fall in by following the curved paths created by immense gravity, spiraling ever closer to the center. Picture a heavy ball on a rubber sheet. Marbles spiral inward, not in straight lines, illustrating how gravity bends space. This is how black holes bend reality, distorting light and matter in their vicinity. They silently shape the universe around them, influencing the motion of stars and even entire galaxies. Their true power lies in warping space and time, sending ripples, gravitational waves, across the cosmos. They are the ultimate test of physics, challenging our understanding of the universe at its most fundamental level, and they remain among the universe's greatest mysteries, inviting us to explore, question, and wonder what lies beyond the event horizon. Black holes come in a surprising variety of sizes and types, each with its own unique origin and mysteries. They are among the most fascinating and extreme objects in the universe, challenging our understanding of physics and the very fabric of space and time. The smallest, still theoretical, are primordial black holes, possibly formed just after the Big Bang, when the universe was less than a second old. These ancient objects might be relics from the dawn of time, created by intense fluctuations in the density of the early cosmos. They could be as tiny as atoms, yet as massive as mountains, packing unimaginable density into a minuscule space. If they exist, they could help explain some of the universe's biggest mysteries, like the nature of dark matter. Next are stellar black holes, born from the violent deaths of massive stars. When a star many times heavier than our sun runs out of fuel, it collapses under its own gravity, triggering a supernova explosion and leaving behind a black hole. These range from 3 to 20 times the mass of our sun, but are only a few dozen miles across, so dense that a teaspoon of their material would outweigh Mount Everest. Our galaxy may contain hundreds of millions of stellar black holes, scattered like invisible mines throughout the Milky Way, each one a silent remnant of a once brilliant star. Then come intermediate mass black holes, the elusive missing link between stellar and supermassive black holes. Their existence is still debated, but evidence is growing. They're hundreds to hundreds of thousands of times the sun's mass, often found in dense star clusters where many stars interact and collide, possibly merging to form these mysterious objects. Some scientists believe they might be the seeds from which supermassive black holes grow, merging and feeding over billions of years to become cosmic giants. Finally, we reach the giants, supermassive black holes. These titans lurk at the centers of galaxies, including our own, shaping the fate of entire star systems. Millions to billions of times the sun's mass. They anchor the centers of galaxies and influence the motion of stars on a galactic scale. The Milky Way's Sagittarius A is 4 million solar masses, a gravitational powerhouse at the heart of our galaxy. But monsters like Phoenix A reach 100 billion suns, dwarfing everything else in the known universe and stretching the limits of our imagination. Their event horizons can swallow entire solar systems, warping space and time so severely that nothing, not even light, can escape their grasp. These are the true gods of gravity, bending the universe to their will and shaping the evolution of galaxies over billions of years. Each type tells a different story of cosmic evolution, revealing how the universe has changed from its fiery beginnings to the vast, mysterious cosmos we see today. Imagine a primordial black hole with the mass of Earth, compressed to less than an inch across. If it passed through the outer solar system, we might never notice, but if it headed for Earth, disaster would strike. Its gravity would pull the planet's crust, oceans, and core toward it, causing massive earthquakes and tidal waves. The black hole would punch through Earth, dragging matter into a superheated disk and unleashing deadly radiation. It would exit the other side, leaving a tunnel of destruction. The planet would explode, reduced to debris, the moon would be flung away, and Earth would become a new asteroid belt. Our world would vanish in silence, erased by a cosmic bullet. All life would end in an instant. The universe would move on, indifferent. Now, imagine a stellar black hole, 10 times the sun's mass, entering the solar system. Its gravity would send comets and asteroids hurtling inward, bombarding the planets. The outer giants would be flung from their orbits or ejected into interstellar space. Moons would scatter, and the solar system's order would collapse. Earth would face a barrage of impacts, boiling oceans and sterilizing the surface. If the planet survived, tidal forces would stretch it into a thin stream, spaghettification. The remains would spiral into the black hole's accretion disk, burning brightly before vanishing forever. The solar system's ancient dance would end in chaos. All that would remain, a glowing disk around a silent, hungry void. The black hole would move on, leaving only destruction behind. The universe would barely notice. Now, a true monster. An intermediate mass black hole, 100,000 times the sun's mass. Even from Jupiter's distance, its gravity would capture Earth, tearing it from the sun. Our new sun would be a blazing accretion disk, bombarding Earth with deadly radiation. Oceans would boil, the atmosphere would vanish, and the surface would be scorched and frozen in turns. Supervolcanoes and earthquakes would tear the planet apart. Life would end quickly, with humanity's last days spent underground. Eventually, Earth would spiral into the black hole, vanishing forever. The process would be slow, but the outcome inevitable. The solar system would be unmade by a single, distant intruder. Now, the ultimate nightmare, a supermassive black hole, 100 billion times the sun's mass, approaches. Its event horizon would swallow our solar system many times over. Space itself would warp. The sky would distort with gravitational lensing. The sun would be torn from its place, captured and devoured by the black hole's accretion disk. Planets would collide or be flung into the void. The solar system's structure would be dismantled in years. For the black hole, this would be trivial. A whale swallowing a speck. Our existence would be erased without a trace. The universe would continue, indifferent to our fate. This is the power lurking in the dark heart of the cosmos. Against it, we are nothing. The ultimate force of gravity would write the final chapter of our story. If Earth survived such a catastrophe, it would likely be ejected, flung into interstellar space as a rogue planet, cast adrift among the stars. Cut off from the sun, temperatures would plummet to unimaginable lows, oceans and atmosphere would freeze solid, life would perish almost instantly, unable to adapt, except perhaps for microbes deep underground, clinging to the last warmth. Even these would die as the planet cooled and geological activity finally ceased. Earth would become a frozen tomb, drifting through the void for eternity, never to return. Our cities and history would be entombed in ice, preserved in the endless darkness. The planet would wander, unseen and forgotten by all, a silent monument to a lost world, echoing through time. The universe would not remember, nor would it care. Black holes aren't just destroyers, they're cosmic laboratories. We study them by watching their effects on nearby stars and matter. At our galaxy's center, stars orbit an invisible mass, Sagittarius A, proving a supermassive black hole lurks there. When black holes feed, their accretion disks shine in X-rays, visible to telescopes like Chandra. By analyzing this light, we learn about their mass and spin. The biggest breakthrough, detecting gravitational waves from merging black holes. LIGO's discovery opened a new window on the universe. Now, we listen to the cosmos's gravitational heartbeat. Black holes reveal the universe's most extreme physics. In their darkness, we find new ways to understand reality. Black holes are the universe at its most extreme, gravity's ultimate expression. They're born from death, yet may hold the key to cosmic creation. To study them is to confront the limits of human understanding. Our journey through these scenarios is a lesson in humility. The universe is vast, powerful, and often violent. Yet, in this terror, there's beauty. Black holes drive us to question, to explore, to learn. They are the ultimate puzzle, challenging our minds. We look up, build better tools, and listen for their whispers. The universe's greatest mysteries are wrapped in darkness, and we are determined to uncover them.